Okay, welcome back. Welcome back to those of you that are watching on the screen, on the stream, that have been devoted enough to stare at our schedule card for the last 30 minutes. It's good of you to stick with us. And if you're in the room, hi. My name's Ian. I lead a team at AWS working on developer relations, technical evangelism. So helping developers understand how they can use AWS across quite a few different topics, actually, to build apps in a different way. And this afternoon, I'm going to be talking about building intelligent chatbots with Amazon Lex, which is a service we announced a little over a year ago now to simplify the process for developers that wanted to use natural language in their applications, so communicate with human beings using human-like conversational interfaces. Actually, a service that shares some of the core concepts and core technology with another Amazon product, which a lot of you will be familiar with, Alexa and the Amazon Echo. So many of the features and capabilities and components within Amazon Lex are common with features, capabilities, and components that exist within the Amazon Echo and exist within the Alexa voice service, which is the cloud-based service that deals with speech recognition, natural language understanding, intent entity extraction from natural language in order to help you use information systems using your voice. Okay, and it's that I wanted to talk about first of all before we get onto the main part of this session. And it's important to say the main part of this session is predicated on one assumption. Okay, and it's very, very important that this assumption is true, or this session will fail. Okay, and that assumption is you all have to have Facebook Messenger installed on your phones. Okay, if you do not have Facebook Messenger installed on your phones, this is going to be the worst demo that you've ever seen in your life, okay? And that goes for people watching on Twitch as well. Facebook Messenger, absolutely essential. If you don't have it, I'm going to look so bad when we get to the demo because nothing's going to happen, okay? So please have that. And when we get there, you will be interacting with a Amazon Lex chatbot live using Facebook Messenger, be able to observe metrics, gather some data about this session, and actually show you how one of these applications works in practice. If you don't have Facebook Messenger, everything that I've just said is going to fail. Okay, so please have that. If you don't have it, install it now. You've got time. Okay, so why do we build Amazon Lex? What is it? And then we'll jump straight into the console and show you some getting started stuff. So if you're old like me, you probably remember, well, maybe there are some people in the room that are with this first generation of computing. This first generation of computing interfaces, like to describe it as the original asynchronous programming model. Okay, not asynchronous because we're using callbacks, asynchronous because you give somebody your punch cards, they take them away, they run them on a machine somewhere, and then a few hours or days later they come back with the results. Okay, that's real asynchronous programming. And of course what we're talking about here is really mainframes, batch processing, simplistic algorithms that are used for data processing. Okay, really at this stage computing was not accessible. Information systems were not accessible. They were only accessible to the small group of wizards that were blessed with direct access to the machine, and then by proxy to people that would, request time on the system in order to run their calculations and get their results. So a long time in the past now, but that's actually where human-computer interaction all started. Okay, it started actually with really poor interfaces that only real experts could use. What happened in the mid to late 70s was research around alternative interfaces. By this time, the command line had been established as a primary mechanism for interaction. But this is where visual analogs started to come into play. So we're thinking about a couple of things, really. The visual analogs that we're all very familiar with today, like pointers and sliders and folders, menus, okay? But also things like skeuomorphism, the idea that when you open a notebook app on your iPad, it has a fake wire spiral binding down the left-hand side, and it looks a little bit like an actual physical notepad that you might write on. It's fallen from favor a little bit now, but there was definitely a belief that this kind of interface design would make machines more accessible to people that were uncomfortable with them. So you saw traits like that creeping into interface design. It's good. It made applications and services more accessible. Okay, so you do have plenty of examples, for example, of young children that are just super familiar with touch interfaces and really get how to interact and manipulate the machine, access information sources, and drive applications using this very natural gesture-based interface model, right? We're all super comfortable with that today. What you've seen over the course of the last 3 years really rise to significant usage, really driven predominantly by the adoption of the Echo, of the physical device that Amazon created and that we sell today, and was actually the most popular product on the Amazon retail website in the US in the run-up to Christmas, believe it or not. The Echo device was the most popular single product. What we've seen is a new generation of conversational interfaces that just makes information services and applications ubiquitously available to anybody that can speak in a supported language, okay? And this has had a really interesting effect. The first thing is it's broken down a few barriers to accessibility that still existed. I saw a user and customer speak at an AWS user group event in Dublin over the course of the last couple of years. Somebody with a severe visual impairment, okay, could hardly see anything, okay? But since they'd got an Echo in their home, they were able to access information sources that the rest of us with working vision all take for granted. Imagine never being able to use Google, never being able to see a list of search results, and never really being able to make a query against an information source like that. How disadvantaged you would be if you couldn't do things like that. And one of the big changes that's been driven by the rise of these voice-based interfaces is that fact that now information systems, they're very young with the touch, yeah, but now the very old or the disabled, the impaired that might not be able to access systems due to those impairments are now able to do so. The other thing that you've got here is the general purpose voice interface, if you want to call it that. So the device, the system, the Alexa voice service does something called intent resolution. It can naturally distinguish between phrases like, what's the weather going to be like tomorrow, and how long is it going to take me to get to the station? Okay, and it figures out what you want to get out of that intent, okay, called intent resolution, works out how to route that to an information source that can provide you with fulfillment to that particular intent, generates natural language and provides it back to you. Okay, so when we're talking about general purpose voice interfaces, it's that capability to do the intent resolution that is really the big leap forward that we've taken in the last few years. We've always had, or for quite a while, had the capability to press a button in a car and say a name and have somebody called, right? But that's in a very narrow namespace, a very narrow scope. It's the general purpose resolution of these wide intent spaces where we might support tens of thousands or hundreds of thousands of different use cases and have the capability to very quickly use a classifier, the kind of classification algorithm that Julian was talking about in some of the earlier sessions, to figure out what that particular collection of words means in terms of the intent options that are available, resolve it down, and then move through the process to fulfill that intent for the customer. This is we're probably starting to now take this for granted. This is a big deal. Okay? This is a really big change in HCI, in human-computer interfaces. Covered that already, I think. So with Lex, it's not the Amazon Echo and it's not Alexa. It's a different service. It's probably just worthwhile exploring why we built this and in what ways is it different from the Echo and what ways is it different from Alexa. So one of the ways in which it's different is with Lex, you can plug different channels or different applications, consider these different front ends, into the engine. Okay, so I might have a mobile app, which is a travel booking app. Okay, I want to allow my customers to search for and book hotels, accommodation, and car hire. Okay, I've already built that. My objective might be to voice enable that existing application. So I don't want wide intent resolution. I actually only want to have 3 intents that are pertinent to the use case that I'm servicing with my app. Okay. With Lex, it's very simple to build a text or voice-based interface, bolt that into an existing application using our Lex API, our runtime API, and accept calls against that API, and then resolve them down to one of those 3 or 4 intents that are required for our particular use case. So I could take my existing travel booking app, add a button to it that says, talk to me, okay? Have a customer press that button and literally say, I want to book a hotel, and then enter into a dialogue with them just by using the Lex API in combination with this existing mobile app. Very, very simple for that very targeted use case. Okay? So that's one useful component of the service. The other thing is I might want to go where my customers already are. We're going to talk about Facebook Messenger later, so don't forget that. Very important part of the demo. Okay? But obviously there are chat platforms that have hundreds of millions or billions of users on them already. Okay? Wouldn't it be nice if you could take your application or take your intelligent agent out into one of these existing communities and interact with your customers via one of these existing platforms, one of these platforms where they're already present. Okay? And that's what you can do with Lex. You can bolt it into Facebook, Slack, Twilio. You can build your own webhooks-based API edge to enable your clients to communicate with Amazon Lex's conversational interface engine from wherever they happen to be, from whatever chat client they happen to be using, whether that is Twitter direct messages, Facebook, Slack, Twilio, or something else that hasn't been invented yet. And you can reuse the same chatbot engine across all of these different channels. Okay? You are hitting the API, you are providing these utterances, these fragments of text. We are connecting that with our natural language understanding engine, resolving those intents down and generating utterances or conversational fragments that go back to your customers to drive this conversational interface, the back and forth of human conversation. Okay, so that's what we're trying to solve for. Simplicity, okay, and the ability to go wide across different platform types, across different channels. The other thing we're trying to solve for, of course, is hiding away, abstracting away some of the heavy lifting associated with building systems of this type. I already mentioned classifiers, where we want to have our 10 or 12 different intents, maybe within our particular use case, have our phrases that are representative examples of those particular intents, and have a pre-trained deep learning model, neural network model, that will allow us to quickly resolve the difference between I want to book a flight and I want to book a car. Okay? And that's one of the things we do in the service. We allow you to provide representative examples of these intents, and then we enable you to simply use deep learning technology to do this intent resolution and figure out what your customers are asking for. Also, in a similar vein, we support entity extraction, and we call these entities slots in Lex speak, in our service terminology, if you like. And slots are useful pieces of information that we need to conclude fulfillment of a particular intent. If I say I want to book a flight, well, that's not quite enough, is it? You know, I just read this morning that you can fly to 180 destinations from Manchester Airport. So even if I said I want to book a flight from Manchester Airport, it's still not enough to do anything meaningful. And I need to know where I want to go to, when I want to travel, what time of day, which carrier, what class of travel. Some of that information is essential, mandatory information to conclude that fulfillment. Some of it might be considered optional. And with Lex, can build a language model for a particular intent that specifies these mandatory and optional slots and automatically generates the language that is required to fulfill the intent by populating those slots. So the system will literally ask me, where do I wish to travel to? On what date and at what time? And if I specified them as mandatory, with which airline and in what class? Okay, so those are conversational fragments that are generated automatically by the engine. As a developer, I just specify the intent and the slots, and then we use another deep learning neural network, a pre-trained model, to generate appropriate language to gather this additional information, enabling that intent to be fulfilled with all of the required data. So you don't have to build the language models, you don't have to build the intent resolution, the entity extraction technology. You're just defining a model for your particular intent, the data that is important to you to that particular intent, and then Lex will do the rest. Okay? But you can also customize, and I'll show you some more customization later. You can customize on slot validation, so business logic or rules. For example, I can't book a flight in the past, can I? But yesterday is a valid date. So for that particular use case, I'd want slot validation. And I can build that in a scalable way by essentially connecting my Amazon Lex chatbot to Lambda functions, AWS Lambda functions, that encode the business logic required to do things like validate slots. Okay? And the same on fulfillment. When it comes to fulfilling my intent, I can link my chatbot to a Lambda function that encodes the business logic required to do the fulfillment. In the case of flight booking, it might be reaching out to a flight booking API that exists on a legacy system and actually executing that booking, receiving a confirmation code back, and turning that confirmation code into a spoken confirmation or written confirmation that a user receives. So I can address some of these scaling, security, availability, business logic challenges by using other AWS services. Actually a broad range of different AWS services, but AWS Lambda is the glue that makes that stuff happen. Okay, we'll explain precisely how later on when we get into the demo and take a look at the docs. Okay, so I think we've covered pretty much everything I wanted to cover on why we built this and what we've built. Just talk a little bit about this. This is important. Okay, so I mentioned before, and we'll just dive a little bit more into language models here because this is one of the really interesting parts of the service in my view. Mentioned before that you can hook on voice-based access to these services, or you can interact with customers through text-based channels, okay? And that means that the language recognition, the language model, is essentially split into two components. There's speech recognition, which is basically what did I say? And when I mean what did I say, I mean what sequence of words did I utter? That's your utterance, okay? So that's the first thing we do. If you submit audio to the Lex engine, we will perform ASR, or automated speech recognition on the audio, extract the words, and then we'll send those words into an NLU engine. This is the natural language understanding engine. And this is the thing that knows the difference between I want to book a flight and I want to book a car, I want to hire a car. You know, so it'll figure out those intents. And that's also the thing that'll do that slot extraction and generate on the outbound this phraseology to enable us to fill out our data model, okay, to enable us to gather the information that we need to fulfill a particular intent or a particular use case within the bot. Okay, so with that, I normally just jump out the slides here and show you a few things, and that's what I intend to do today as well. Okay, so I'm in the AWS console here. I'm operating in the North Virginia region. This service is available in two regions right now, North Virginia, US East 1, and EU West 1 over in Ireland. So you can run these endpoints locally. It just so happens that when I started building on Lex, we hadn't actually launched the service in EU West 1, so that's why my examples are running in North Virginia, but there's no other reason for it beyond that. And I guess the fact that I sometimes like to experiment in integrating brand new AWS services into some of these demos, which I'll show you one of later, which is only available in that region. Could call it internationally, but the latency is going to be improved if I'm local to it. That's one of the reasons that I operate there. Like most AWS services, you'll find that we have representative examples of the service that you can create directly within the console. We call this a first run experience if you're not familiar with that terminology. So something that's intended to make it easier for the developers to get started with a service. And in this particular case, we have several different examples, okay? These are templatized chatbots built using Lex that you can choose to deploy directly into your account for demo purposes, or, as I've done myself, as the basis for other applications that you might build through customization, starting with the framework, a base framework, which includes certain helpful functions and helpers that have been established to help you do things that you can then extend as the basis for your own applications. And when I get to show you my more involved example in a few minutes, it's actually built off this book trip example that you can see here. Okay? But for now, we're going to provision an exact copy of the template application, which is called book trip. Okay? We're not going to target on children, so we don't need to select that. And we hit create. And what's happening now is the template application is being deployed into my own AWS account, okay? And you'll see in the background, move this around, okay? No, I can't. So in the background, you'll see a few things that I want to quickly talk about. In the top part of the screen, hidden behind this modal dialog, you'll see these example phrases here, okay? These are associated with the book car intent that you can see top left. See that? Yeah? So what I'm doing here is providing these representative phrases that are examples of this particular intent, or examples of the phraseology that users might use if they wish to invoke this particular intent. Reserve a car, make a car reservation, book a car, okay? And over time, I can develop a longer list of examples using some reporting functionality that I'm going to show you in a second, okay? But there's 3 examples there right now. And then I have my slots. Some of the slots, you'll notice, start with Amazon dot, okay? These are our built-ins, okay? These are essentially data types that Amazon has already populated to simplify the process of using them, okay? So these are language models for particular entities that have been pre-trained with training data, which allows us to resolve them. So for example, in the US city slot, we're going to have pre-populated the language model there with a large number of different US cities, which will enable the natural language engine to resolve and pick those cities out when someone says them. So if I say Detroit or Chicago or Los Angeles, that will be in the training data. That will help our neural network pick out those particular entities from the spoken or written word, okay? We've also got a custom slot at the bottom, which you can see here for car type, okay? And we can define custom slot types, import our own data, and train our own slots using our own custom data sets. Okay, those can be large or small. In the case of car types, it's not going to be a particularly big training set. Probably luxury, large, mid-size, compact, whatever our phrases are. And we can actually, on the slot, restrict to a specific set of slot values and synonyms, or we can allow the language modeling engine to automatically extend the values for that slot to a larger pool using its knowledge of the English language, its trained knowledge of the English language. Okay, and I'll show you an example of upstreaming custom slot creation later on, where we're actually going to use a publicly available data set to preload a custom slot with a large training set. Okay, we can programmatically drive that using a little bit of data science, a little bit of data manipulation, really, I'd call it, rather than data science, plus the Lex model building API to import data sets and build slots automatically using that kind of approach. That's quite a powerful technique that I've been experimenting with recently. Okay, and then we have our bot deployed, essentially, and we can talk to it. We can say, book a car. In which city do I want to rent a car? What day do I want to start my rental? So you see there's no validation there. I can say I want to rent a car yesterday. Obviously it's impossible to do that and I should reject that, shouldn't I? But at this stage there's nothing hooked in behind the language model, okay, to validate any of these entries. It's just going to believe whatever I tell it, accept whatever I tell it, as long as it's valid data. But you'll notice, for example, I put yesterday, right? But pickup date has been resolved to an ISO date. Again, this is by virtue of the fact that we're using these built-ins. It gives me the capability to resolve spoken human dates into system representations, into ISO dates that I can then work with programmatically, of course. So I could say next Tuesday, last Christmas Day, 2 weeks on Friday, and it will essentially pick out the appropriate ISO date using that built-in language model. It's quite sophisticated. It allows us to use natural language rather than having to say, 2018 02 06, which means something different in the US to what it means in Europe. Okay, so those language nuances are taken into account by virtue of the fact that we can use natural language dates in interaction. Actually, really useful feature. So what about adding validation? So you'll see that I've got the ability to hook in a Lambda function for initialization and validation. Okay, so to do that, I obviously need to provision a Lambda function within my account, which I will do. And if you're not familiar with Lambda, this is our serverless computing service. It allows us to execute code within a managed runtime environment. Okay, it uses containers for deployment, but that is an abstraction layer that you don't really need to worry about. Essentially, what we're going to do is grab a Lambda function, which is in our blueprints repository here, which is the booktrip Python backend function. Okay, and we're going to configure and deploy that. This role just allows the function to run and record logging data into another service that we've got so we can gather metrics and do debugging. Okay, and I'll just hit create function on that. Okay, that's it. We deployed it already. That was quick. Now if I go back to my Lex console, I can specify, I need to reload this actually to grab my list again. I can have my Lambda function for initialization, booktrip backend, give Lex permission to invoke, and I'll do the same on the fulfillment as well. It's the same backend function for both. Save that intent, and I can test again. Now if I go book a car, rent in London, and I want to start yesterday. Okay. What am I doing here? Okay, build, sorry. Yeah, my mistake. Got to rebuild. So in rebuilding, I'm refreshing the configuration of the bot, and also if I've made changes to the language model, these will get propagated back into the network, into the neural network, and those language model changes will then be reflected in the capabilities of the bot from this point. So I just need to do that very quickly. Sorry, that will then replace the back end and initialize the Lambda function on interaction. While that happens, I'll just take a look at the docs and explain a little bit more about what's happening here. So when I converse with the bot, either by text or by voice, if I have that initialization and validation checkbox checked and a specific Lambda function nominated for invocation on that event type, every time I send an utterance to the bot, my Lambda function will get invoked, and my Lambda function will receive a fixed format document that contains information, data, about the utterance that I've just given. Okay, information post the Lex language engine having worked on the utterance. Okay, so there's some pre-processing that takes place in the conversational engine, and then my Lambda function gets called. And this is the document format for those requests. Okay, and you'll see that things like the current intent is specified, the slots that I've populated are specified, the confirmation status, the name of the bot, the alias, the user ID of the user, which can be used for session maintenance, and also other data is passed into my Lambda function in this fixed format. So in my Lambda function, I'm essentially going to write a handler that understands how to interpret that document, okay, how to operate on that document, how to extract slots for validation, how to fulfill the intent if the fulfill intent flag is set, how to work with the input transcript, for example, if that's something that I need to do. So it's by writing a function that is capable of interpreting and operating upon the data structure that is represented in that document that I do this enrichment, okay, that I create more sophistication in the validation, that I create things like random responses, that I build any advanced functionality beyond the functionality that is inherent within the front end. Okay, so it's there is where I introduce the richness. And now if I test again here, we do not currently support London as a valid destination. Okay, so my validation is now in play, and the slot of pickup location, is it called? Pickup city has been sent over to my validation function with the value London specified in it, okay? My Lambda function is reading that, it's interpreting it, validating it against the list of valid values, and then it's actually zeroing the slot, and then generating a confirmation message, a response message, which says that isn't a valid destination, a valid pickup city. And that's how I get the back and forth of the rich conversational interface. Okay? Now, I'd recommend, of course, taking a look at the code base for the validator. It's a very interesting way to learn more about how to build systems of this type. I can find this. Okay, so this is our handler function. You can see that we've got an intent router here. So we receive our event, which is the data structure that I talked about, which is represented in that documentation set that I showed you. From that, we can extract the current intent, which you can see taking place here. And then we can enter another function, which is the target of this intent router, which you can see here. So the book hotel or the book car intent. And this is where we represent the logic associated with validating, generating responses. Okay? And we have quite a few different helper functions within this code base that, as I mentioned earlier, we can reuse in building our own backends. Okay, so if you're going to get into serious development on Lex, I'd really recommend taking a look at the way some of these things are implemented. There's some very interesting stuff here around response generation. So if I need to generate a utterance back out to the client to, for example, elicit a slot, I need a specific fixed format document for that, okay, where I set certain attributes in my response, send back that fixed format response. The Lex engine will interpret that. It will understand that the action is re-elicit a slot. It will generate the right context to the client in order to elicit that slot. So by using this elicit slot function here, I can quickly build up those template messages, dispatch them back to Lex, and have them returned back to my clients, and therefore drive the conversational back and forth that's required to build these kinds of interfaces. Okay, so I'd recommend taking a look at that. That's probably enough on the built-ins, on those built-in demos. Next thing to do, I think, is get you working with one of these systems. So this is where we need Facebook Messenger. Don't forget that. It's really important. Okay. Two things you can do here. Okay. If you've got a phone with Facebook Messenger on it, you can open the Facebook Messenger app. You can go to the People button on the bottom, which is third from left on the right-hand side. And you'll notice this very little known feature called scan code, okay? If you hit that scan code feature, you'll see a circle appear on your screen that looks like that, okay? Try and get that picture of my face with the blue ring in the circle. If you're sitting at the middle of the room, it might be difficult, okay? So if you are sitting at the middle of the room, you can simply search for ian.massingham.aws in the search function. And if you're remote on Twitch, you can go to facebook.com/ian.massingham.aws, and you'll see there's a message me button in the web interface as well that you can use, okay? I'll just do the same. Let's turn off mirroring for a second. Okay, so I'll do this. Right, and for those of you that aren't playing along with the demo, let me show you how this goes in dialogue. So what you've got here is a bot. You can say help, okay? And it will then give you some guidance about what it does. And it says, right now, I can take feedback or rate sessions where you've seen Ian Massingham speak. Just say I want to rate a session or I want to leave feedback. I need to know the date, time, location, and session identifier. Okay, so if I say I want to rate a session, and I could do this using voice if I had a voice client connected to the system. I've got text via the Facebook channel, okay? It will ask me which session I want to rate. I can say anything there pretty much. Say Lex, okay? It's today, okay? We are in London, okay? And then it will ask me to provide a rating. And I can give invalid data, and that will be trapped, and I'll be asked to enter a valid score. So there is validation here, both on location, date, and on scores. Okay, I'm going to rate myself 3, probably not to skew the results too much. Do I want to submit this rating? Yes, I do. And that's it. Okay, so I've been through that slot elicitation process. I've got some validation in there, and I've captured at the end of it a JSON object that contains session identifier, date, location, and a score, right? Just those 4 attributes. They get packaged up, and using the fulfillment code within my function, oh, you see many people are talking to me. Okay, okay. I'm hot and popular. Don't forget to like my page as well, okay. And you'll see that in the back end, we've got another one of those Lambda functions, actually based off the book trip function, okay? But it's got a little bit more functionality in it, okay? First of all, you'll notice that the intent router has a little bit more width in it. There are a few different intents, okay? And what I discovered in putting this demo into production in the early stages was, guess what? Users would do things that I didn't expect in using the demo. So no design ever survives first contact with an actual user, right? That's like, no plan survives first contact with the enemy. So I found out that people like to say thank you quite a lot. And I didn't have an intent to answer people that said thank you. So you can try saying thank you. You'll get some random responses back where the bot says no problem, or you're welcome, or just let me know if I can help with anything else in the future, which uses just a bit of randomization in the response to try and make things feel a little bit more human-like. I also discovered that without a cancel request intent, there was no quick and easy way to let somebody quit a session. So I created an intent for cancel request as well. And this underlines, reveals something about the way in which the Lex language model works, which is that intent resolution is always active. So even if you're in dialogue about fulfilling slots for a particular intent that you've already activated, which is your current intent, okay? Intent resolution is still active. So you can then say cancel or thank you. You'll get kicked out of the intent that you're currently in because the utterance that you give is more probable to resolve to another intent than it is to fulfill a slot. Okay? And this allows you to build these escape routes which wouldn't exist if you were locked into a specific intent. You'd have to wait for your session to expire. So that's really a usability feature, but it's a usability feature that you need to know about because it can have unexpected consequences if you're not aware of the fact that the intent resolution engine is constantly active within the language model at the front end. Okay, so that's a kind of thing to know about in building systems. And then I have a testing intent, which I obviously use for certain test features. And I'm just getting started with a new intent, which is not implemented at the front end, but is a sticker request intent, where you'll be able to request AWS stickers. And this is where my custom slot comes in for postcode capture, which I'll show you in a little while. So I'm building other stuff into this system as well. Then we've got fulfillment of various intent types. So thanks, for example. Here you've got your random options. No problem, you're welcome, happy to help, that's fine, thank you, yada, yada, yada. Okay, pick one at random and we'll return it with a close, session, and fulfilled document type. Okay, yeah?
Can you only respond to text, or can you respond to like a pause?
Oh, sorry, can you only respond to text or can you respond to pauses? So there's timeout, okay, which is set in the bot at the front end. So how long am I going to wait before we essentially clear down the session and reset it? But outside of that, I guess there's a break point at which we conclude an utterance. So we consider that utterance complete, we ship it off to the engine.
Or like, do you want to still carry out if someone's not responding in a while?
I don't think you can do that, actually. I think the timeout is set in the language engine at the front end, and that's a hard-coded value for each bot that you create. Okay, but you can offer up different options to customers. If a customer gives a response which is not definitive, so a response which doesn't particularly resolve down, you could have a general purpose capture message which says, I'm not sure what you want, okay, and then allow the timer to run again until the customer says something else, and you have that in the front end as well, okay. So we have these intents, and then we have the more comprehensively implemented rate session intent, okay. You might notice this delegate here, okay? So when we return this delegate document type, what we're saying there is, Lex front end, you decide what to do next, okay? And that's essentially handing control back over to the language engine from the validation function and saying, you decide what to ask for, okay? And that's when we'll then elicit for another slot if a slot is currently vacant. So you can hand control back to the engine, or you can retain fine-grained control by doing your own elicitation for slots or issuing your own specific messages, for example. Okay, so your functions need to work in concert with the front end. That's something that I've learned with working with the system, actually. And then I have my fulfillment action here, okay, and I'm going to show you the overall system architecture because there's quite a few other AWS services that are involved in this beyond the Lambda function to try and make it really scalable and really slick in terms of the way in which it works. Okay, so we'll jump back onto the slides and just show you that. First thing is this. So this is the overall architecture of the function, okay, with our intent router, with our handlers for our implemented intents. Thanks, cancel request, help me is what prints out that message saying this is what I do. Rate session and provide feedback. The rate session and provide feedback will be triggered recursively until we populate all of the slots through this slot elicitation loop that we go through. If we've got a piece of data which is missing, well, whenever we receive a slot, we'll validate it, okay? And if it's invalid, we'll clear it. And then we'll check if all of our slots are populated, and if they're not, we'll re-elicit for ones that are empty. So we'll go through that validation loop, clearing out the slots until we've got valid values everywhere that we need them. Then we post our rate sessions directly to a Kinesis stream, put the populated JSON object in the stream, okay, and then it goes somewhere else. And if we're doing sentiment enrichment for feedback, we actually do sentiment assessment of the comments. Because we don't, we care about the comments, but we care more about whether the comments are positive or negative, right? So we can derive a metric from the comments. So in that case, we use another AWS service, which is in preview called Amazon Comprehend. It's a natural language processing engine that includes sentiment analysis. We package up the feedback text, send it over there, get a positive, negative, or neutral back from that other API, enrich that into our fulfillment object, and then package up all that and send all that into Kinesis. So those are our two document types, a feedback document or a numerical rating document. Those are the two things that we capture. And then at the back end, once we've got the sentiment analysis done, drop that into a Kinesis stream. We then use another service called Kinesis Firehose to reliably deliver those JSON objects into an Elasticsearch cluster, and from there we have a simple visualization dashboard with Kibana at the back end. Okay, that's it. The whole thing is managed in CodeStar, which is our CI/CD pipeline, using SAM and CloudFormation. Okay, and the whole thing is instrumented with another new service that we've got called AWS X-Ray, which allows us to measure the performance of our Lambda functions, observe the performance of dependent APIs, and actually observe things like mean time to reply from the internal or third-party APIs that we might be using as well. So it's a pretty good example of a fully built serverless application. So let's go here. Let's reload this. Possible my SSH tunnel has dropped. Yes, it has. Yeah. Is it going to work for me or not? The whole demo falls apart because my SSH tunnel doesn't work. After all that, no, it doesn't. We're okay, I think. Okay, let's try that again. Okay, good. So we're going to get our dashboard now of data. Okay, and we're going to look at today, obviously, because that's the scope that we're looking at. Okay, and we want our dashboard. Okay, so we got 32 ratings that came in from people that interacted with the bot. We got 3 neutral and 2 positive pieces of feedback, so only 5 pieces of feedback in total. We've got our distribution of scores here. Average score was 4.31. So our distribution, this is our complete feedback down here. Interesting, brilliant, and random numerical value is okay and great. So that is the raw feedback that a few of you either on the stream or in the room provided to the feedback intent. Your scores are those numerical values, 32 of those were submitted, and we've got the data streaming through that Kinesis stream, getting deposited in Elasticsearch in the form of these documents that you can see here. So that's a session rating document just there. Okay, and that person scored us 4. And this ID here is the unique ID associated with that individual's Facebook account. Okay, so we're not capturing personal data per se, but we do have a session identifier, a user identifier, which can be used to link that user to their particular session in Facebook again. And it's probably worthwhile just talking about how this channel integration works, because this is a really interesting part of the service in my view. So in integrating with services like Facebook, Twilio and Slack that we have built-in integration for, or Kik, which is a new integration, these work by using webhooks. Okay, so we're establishing 2 webhook API endpoints, one in AWS that the service provides, okay, where we receive messages from the Facebook Messenger API. Each time you enter a message into my Facebook page, Facebook package that up into a JSON object and fire it over to my API endpoint with some shared secrets for authentication. Okay, and that includes your session ID, so I know that's how I know who you are, both for the session and for your unique user ID. And then in Facebook's Messenger API, they establish something the same in their infrastructure, their webhook endpoint. And when I want to generate an utterance back to you, Lex hits that API endpoint, validates, sends a specific document format, and that appears in Messenger for you. Okay? So that is something that we make it really simple to create for Facebook, Kik, Slack, and Twilio. But you can also implement the same thing with third-party messaging systems. A colleague in my team, Randall Hunt, has built exactly the same thing for Twitter using something called the Twitter Account Activity API. It's exactly the same architecture. 2 webhooks, one in Twitter's infrastructure and one in ours. When you send a direct message to a particular Twitter account, that hits our webhook. We get that message content. We can operate upon it using the bot. And going back the same way, we hit a specific webhook in Twitter's infrastructure, and that appears in your Twitter DM. Okay, we construct a message which drives that. Okay, how are we doing for time? 15 minutes. One thing I said I would show you. There's 2 things I'm going to show you. So one of them is response cards. Okay, so the test intent. Okay, so I can fulfill that using a slot value of A for which feature to test. If I do that again, okay, and I put G in there, another letter of the alphabet, you'll see that I get this card back, this response card back. Okay, now these response cards are supported today on Facebook and on Slack. Okay, and they're nice because if I was on my phone, each one of those buttons would be touch enabled. Okay, so if I've got a small number of options that I want to present to a client, and I know that the client is likely to be on a touch-enabled device, I can generate those response cards with those URL buttons in them, and customers can directly select an option without having to type. It's really good for things like confirmation dialogues. Yes or no? Are you sure you want to do this? Yes or no? Just yes or no. Or I've got small or medium or large available. Do you want a medium or a large item, M or L? Okay, so that is a really neat feature for integrating with the touch interface on devices like this. So we support that. And Slack have similar cards. You can actually enrich them a little bit more. We support that for Slack as well. The details vary, but the response document format that we use is the same. Okay, so create a card, specify the value options, and we'll take care of the work of transcoding that into the right response format for the particular platform that the message is going to be delivered on. That's pretty nice. Okay, and then the other thing I was going to show is slot preloading. Okay, and for slot preloading, I've got a Jupyter notebook here, which is about UK postcodes. Okay, so one of the things I want to do with my dispatch stickers intent is to automatically recognize postcodes for users. Turns out there are around 250,000 UK postcodes, and we don't have a default slot type for postcodes today. So I started thinking about how could I resolve this issue. Okay, so I found a publicly available postcode file, which is available on the web, okay, which has a CSV file with this document format in it. And I've got a bit of pandas data manipulation to extract those postcodes, sample 1,000 postcodes out of the 250,000 postcodes in the UK, which is more than enough to train the model, actually. Okay, and then I use this. There's 2 APIs for Lex. Okay, we've got a runtime API, which is where we send our utterances and get back our responses using the language model. But we've also got a control plane API, if you want, which is for updating models, creating models. Okay, so for creating bots and updating bots. And for that API, there's a get slot type, okay, and a put slot type method, okay. And there I can programmatically read and write data into slots. So if I'm going to build a pipeline that brings in a publicly available data set to use that data for training for a particular slot type, it's a really good way to do it. So what I do here is sample 1,000 UK postcodes out of the publicly available data set, and I push those in to a custom slot type for the UK postcode. And I could build a pipeline there which automated that process quite easily if I've got a data set which I might store inside another database as part of my build pipeline for my bot. So you can take out some of the stuff which is less simple to do in the console at scale and turn that into part of your automated pipeline. As part of deploying my bot with my weekly build, I could automatically rebuild my slots and push them in using the API, using that kind of approach. Actually a really neat way of doing it. Okay, I think that is everything that I wanted to talk about. Let's just see if we've got any more scores. 2 more people decided to score me. Unfortunately, those people, they did take the average up slightly, so keep scoring me at 5. Okay, that's great. Thank you very much. I think that's everything that I wanted to talk about. Does anybody have any questions? We've got a few minutes before Julian's up. Yeah.
The postcode example.
Yeah.
They were obviously pre-formatted with the space in the middle.
Yep.
Would you be best to train send kind of both variants, kind of the space without, or would Lex take care?
Yeah, so the question here is actually, it's a good point. I didn't think of that, but I should have done. So how do we know whether a user is going to type in the postcode in the right format or not? The answer is we don't. Okay, so you're probably right that we do want to have in my data set several different variants of the postcode, capitals, lowercase, uppercase, with and without spaces. So I need to modify my pipeline to build a bit of that human-like randomness into the value set. But again, that's something that I probably wouldn't want to do in the console. It's actually something that would be quite simple to do using pandas, where you could randomize and sample the data set randomly and create these different variants. So that's a really good example for why you should automate slot building at scale. Yeah. Any other questions? Yes, at the back.
Yeah, you mentioned the use case for Alexa sort of if you've got existing applications or you want to quickly integrate into
Yeah.
Alexa. Easy enough to get, if you've done that effort, to then actually get it to Alexa.
So that's a perfect question. The question is, how easy it is to port chatbots between Lex and Alexa, so between our system that is intended for broad usage and Alexa, which is intended for deployment principally on the Amazon Echo, but you can use the Alexa voice service on other devices as well. That's a really good question. I didn't plan it, but wish I had, because in the last quarter of last year, we introduced model export. So you can build a chatbot model in Amazon Lex and then export it directly as an Alexa skill. It's only unidirectional right now. So you build in Lex, you can export it, and you can create a template Alexa skill that you can import into the Alexa skill console and start to use as the basis for building your Echo or Alexa voice service specific version of that service. The built-ins, by the way, are consistent across both services. So those data types that you saw, Amazon, US city, date, they're the same that you'll have in the Alexa models as well. So there's a lot of portability between the two. You're probably going to want to test and debug on the other side, but it's certainly simpler than it was where you had to previously build autonomously in both of the systems. Q here, yeah.
If I've already got Q-bots and stuff like that in my infrastructure within my company, how would I integrate
If you've already got what, sorry?
Q-bots, something like that?
Okay.
The whole kind of bot technology that I've used, the open source technology.
Yeah.
How would you see that integrating into this ecosystem?
So the question is, if you've already got Q-bots in your infrastructure, how do you integrate them? I'm not actually familiar with that, so I can't speak for the exact integration points that you would use. As I mentioned before, you have essentially a decoupled system here. You have Lex for intent resolution, entity extraction, okay, and the ability to do natural language generation to populate entities or slots within a particular intent. And then you have Lambda, which is your business logic. Okay, so depending on what's in your system, you could take some of the business logic that you've got in that system and migrate it into Lambda. Okay, but I suspect that Lex will be replacing some of the natural language understanding capability that's at the front of that tool. I'm not very familiar with it, but I suspect that it will replace some of that. So that would be not overlapping, and you would probably replace the front end with Lex. Okay. Yeah, we've got your question, yeah?
Do you have any tools or features to test your AWS Lambda functions without having to rebuild?
Do we have tools or features to test AWS Lambda functions without having to rebuild? Yes, we do. There is a test harness within the AWS Lambda console. So you could create your own Lex format documents, okay, so your own requests using the document format that I showed you earlier, okay? You could programmatically inject those into your Lambda functions, and you could monitor the responses that you got back. You can do that in the Lambda console. More likely to do it inside something like AWS Cloud9, which is our new cloud-based IDE, which supports testing harnesses for Lambda functions. So you'd basically write your test cases as request documents and issue them to your Lambda functions and then monitor the responses that you got back. I think there was one other thing that I wanted to show, actually. Oh, there's one other thing that I forgot to show in the demo, which you just reminded me about when you started talking about optimization there. So in monitoring here, there's an utterances capability. So one of the things that you can observe, should I jump onto my other bot, session feedback bot? So one of the things that you can observe is missed utterances. Okay, so I've obviously got my intent resolution and I've got my slot extraction models. Those are classification models. So when somebody says, I want to book a flight, what we're actually doing is establishing how likely that it is that that particular utterance maps into one of our specified intents. Okay? If it falls below a probability threshold, we put it in this bucket, which is the missed utterance bucket. Okay? And what we can do then is say, right, that one is obviously associated with rate session, right? It's I'd like to leave a rating. So we can go like this. So we can quickly add to our classification model utterances that are falling below our probability threshold but should not fall below it, because that's a really useful tool in evolving your bot over time to make it more accurate. And you'll notice if you look at things like the providing feedback intent, I'd like to leave a rating is now added to the bottom of that. But I only started with a couple of these, and I started with the idea of scoring. I've observed that most people didn't say score, they said rate. So I was getting a lot of missed utterances because I want to score a session and I want to rate a session, well, you probably wouldn't in first instance as an algorithm think those were the same thing. So you can extend the coverage of your model and therefore extend the probability model and get more of these prospective intents captured into the right bucket with the right degree of certainty so that they become resolved intents and therefore drive the intelligent nature of the system. Okay, we're pretty much out of time. I'm going to give Julian a few minutes to take over. Like my page on Facebook, facebook.com/ian.massingham.aws. And maybe if you get home later, you can give me a few more fives. And if you're on the stream, give me a few more fives. Okay, thank you. It's been great to be here.